Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about absolute extrema.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Y equals a negative 1/6 times x plus 1 to the 7/3 power, plus 14 over 3 times an x plus 1 to the 1/3 power, and we want to find all points of absolute minima and maxima on our given interval from -5 to 0. The first thing I want to do is find my derivative, and this one's a doozy. F prime of x here, but we take our time. Negative 1/6 stays out front, bring down the exponent 7/3. Multiply by the inside, that x plus 1. Exponent gets subtracted by 1, and 7/3 minus 1 is a 4/3. Multiply the derivative of the inside, which is just 1. Plus 14/3 times, exponent comes down a 1/3. The inside is an x plus 1. The exponent gets subtracted by 1, and 1/3 minus 1 is a negative 2/3. And multiply by the derivative inside, which is just a 1. From there, let's go simplify what we can. Okay. Well, negative 1 times a 7, okay, up here. Negative 1 times 7 is a positive set, or negative 7. I don't even know any of that. And then we have an x plus 1 to the 4/3 power over, that's 6 times 3, 18 in the denominator. And I'm going to leave some space here because I'm going to use that in a minute. Plus 14 times 1 is that 14 in the numerator. Okay. Denominator, 3 times 3 is 9. And then we bring down this x plus 1 to the in the denominator and have it to a positive 2/3 power. Okay. Now these are just fractions, and when we add fractions we need to have a common denominator. So what do we do? Well, I want to have an 18 here on this side, so I'm going to multiply this half here by a 2 over 2. 2 times 2 would give me that 18. The first fraction I'm going to multiply, I have the 18 now matched up, but I'll multiply it by an x plus 1 to the 2/3 power over itself. Same technique when we add just normal fractions, just with some expressions now. Then from here we simplify. F prime of x is equal to, well, multiply this kind of out here. We have negative 7, we have an x plus 1 right there, and we add the exponents, and so we have 6/3 now. Alright, same base, add the exponents. Plus, because it's all going to be under one big thing, 14 times 2, which is a 28. All over this 18 times an x plus 1 to the 2/3 power, which is our common denominator. From here, we're going to simplify this slightly. I'll kind of zigzag a little here to use all the space we can, because we'll need it. Alright, there we go. Okay. Well, multiplying this out, well, 6/3 is just the same thing as a 2 power, right? 6/3 is the same thing as a 2 power, so I'm going to remove that and put a 2 right here. Then from there, since it's squared, let's go multiply that out. Negative 7 times, we have x times itself is x squared, plus that comes out to be a 2x plus a 1 as such. Okay? And then we have the plus 28, almost said 18, over an 18 down there, and an x plus 1 to the 2/3 power. Let's keep simplifying. Let's do the f prime of x right here. Okay? Zigzagging back over here so we can kind of see that, just so you know where it's coming from. Alright, multiply the negative 7 across. Negative 7 times x squared is a negative 7x squared. Multiply by the 2 is negative 14x. And then negative 7 times 1 is a negative 7 plus 28 over 18 times an x plus 1 over 2/3. Can't forget that. Keep on simplifying, combine our like terms. Negative 7 and 28, it's a positive 21. So negative 7x squared minus 14x plus a 21 all over 18 over x plus 1 to the 2/3 power. Okay. It's at this point we want to, well, find our critical values. We set it equal to 0. So we're going to enter numerator and denominator each equals 0. Numerator is when it's equal to 0, denominator where it's undefined. So we have a negative 7x squared minus 14x plus 21 equal to 0. And then the 18 times the x plus 1 to the 2/3 power equal to 0. Okay? Alright, let's deal with this one first. If I pull out a negative 7 from all parts, I'm left with a positive x squared plus a 2x plus 3 equals 0, and that's a little easier to factor. Divide both sides by negative 7, we can just eliminate that. This factors right here equal to 0, and it's an x plus a 3 and an x minus a 1. Set them equal to 0, x plus 3 equals 0, x plus 1 equals 0. And so x, we can see, equals a negative 3, this is a minus 1. Negative 3 and a positive 1 right there. The second part here, we said equals 0, divide both sides by 18. Don't really need that. We can multiply both sides to the 3/2 power to eliminate that. And 0 is being wonderful, it's just still 0. So we have x plus 1 equals 0, and x equals a negative 1 there. So we have 3 values here to test, and we want to see if they're actually within our interval. Well, 2 of them are, but this one right here is not in our interval. It's just outside that negative 5 to 0. And so doing my first derivative test, we want to make it a little kind of nice, a little different here. Negative 5, negative 3, and negative 1, as well as endpoint of 0. But we know we can't really include that, so let's put like a little parenthesis kind of showing where we're at there. Okay? So I'm going to pick a value between negative 5 and negative 3 and plug it into my derivative, which we found, and see what it comes out to be. And I picked f prime of negative 4. I didn't give myself much room, but it's equal to approximately negative 0.9348. And it's a negative, so we are decreasing on that interval. Okay? To give myself a little more room, put a little arrow here. Between negative 3 and negative 1, I found f prime of a negative 2, and that came out to be approximately a 1.1667. That's positive, that's what I really care about, and we're increasing there. Between negative 1 and 0, I picked a negative 0.5, so f prime, again, f prime of 0 or negative 0.5, and that came out to be a positive 2.315. I just care that it's positive and we're increasing. So what's going on here? Well, within this interval from negative 5, we're not including negative 5, but right afterwards we start decreasing down to negative 3. Then we increase to negative 1, and then we keep on increasing to 0. And so negative 3 is actually going to be our absolute minimum here, because it's everywhere to the left is decreasing towards it, and after that it keeps going up. So we have our absolute minimum happening at negative 3, and nowhere else we can claim we have an absolute maxima, because we can't have maximas at our endpoints, and we don't even have a relative minimum maximum going on here at negative 1. And so we have an absolute minimum at the coordinate point, and I found that here, f of f of negative 3 came out to be a negative 4 third root of 2. So our absolute minimum happens at the coordinate point, negative 3 comma negative 4 third root of 2. And plug into our original equation, and we have no absolute maxima going on here. So again, our final answer, an absolute minimum at negative 3 comma negative 4 third root of 2, and we have no absolute maximum. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.